0 times infinity is not 0. Look, guys, I just have to get this off my chest. I see a lot of really low effort, annoying math content on YouTube. You know what I'm talking about. What is 8 divided by 2 times 2 plus 2? The type of stuff that creates controversy because of stupid technicalities. It's not a real question, it's just purposely making your notation confusing to just confuse the audience. A couple more I've seen are like, is 1 over infinity equal to 0? Is 0.9 repeating equal to 1? I think these are also a little irritating, but there is some value to be had from learning about them. But I wanted to talk about a special problem. 0 times infinity. Now, if you've taken a calculus class before, you probably know the answer, but the explanation is a little bit confusing in my opinion. And yes, this problem has been solved before. There are tons of explanations on YouTube, and I linked a few in the description. But I wanted to focus on a separate part of it that I feel doesn't get talked about enough. I want to focus on two specific arguments for why 0 times infinity seems like it should be equal to 0, but isn't. Let's get started with the first one. 0 times anything is 0. So of course, by extension, 0 times infinity should also be 0, right? Well, not really. Turns out your first grade math teacher was lying to you. Multiplication is an operation that takes in two numbers. Infinity is not a number. Multiplication is not defined for the case where one side of the operation is not a number. It's kind of an annoying explanation, but it's true. We're just not allowed to do that. It's the same way that you're just not allowed to divide by 0. Both sides of the multiplication operator have to be numbers. And now for the second argument. Multiplication is just repeated addition, right? That's to say, 0 times 2 is 0 plus 0. 0 times 3 is 0 plus 0 plus 0. And so 0 times infinity is 0 plus 0 plus 0 plus dot dot dot. Turns out this is wrong, even though it makes a lot of intuitive sense. The reason it's wrong is pretty subtle. At its core, it boils down to one very simple reason. Ready for it? Here we go. The equal sign only works if both sides are numbers. As in the thing on the left and the thing on the right, both have to be numbers. It's just like how in multiplication the two operators have to be numbers, or how in division the second number is not allowed to be 0. But how does that disprove the repeated addition explanation, you might ask? Well, look at this equation. This equation represents the core premise of the argument. But it turns out the equation is invalid. Infinity and dot 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 are not numbers, so you can't say that the value on the right is equal to the value on the left. Again, the equal sign only works if both sides are numbers. Now, mathematicians have invented a tool to resolve these types of issues in equations, and that operator is called the limit operator. You heard me right. The equations don't make sense, so we invented something new to make them make sense. The limit is basically a function that can take some form of infinity, and if it converges, it can collapse the infinity into a finite number. For example, the limit as x approaches infinity of the summation of n equals 0 to x for 0. Even though there's an infinity in the expression, the limit operator can be used to collapse the infinity to a finite number. This is allowed because the summation converges. But now let's try for 0 times infinity. The limit as x approaches 0 and y approaches infinity of xy does not converge. Since the limit doesn't converge, you cannot collapse the infinity to a finite number. That means that taking the limit of both sides of the equation is invalid. So finally, the equation is false. Now you might ask why I represented 0 times infinity as the limit like I did, and I'm going to leave that as an exercise to you, the reader. I encourage you to use Wolfram Alpha or do some more digging on your own, The channel Bri the Math Guy has some great videos on this topic, so please go give them a watch. Anyway, that's all I have for the video. I hope you guys learned something. I actually watch a lot of math content on YouTube. I don't really know what it's about, I just find it really addicting. It's like my secret guilty pleasure, except it's not bad for me. Anyway, this is probably going to be the last math video I make, but thanks so much for watching if you got this far. And if you're into gaming type content, feel free to like, subscribe, and check out my other videos. I have a lot more of that stuff on this channel. Thanks so much for watching, and have a great day.